All right. Well, I'm going to go ahead and get going to keep us on time. So I'm Steve Higgins, the director of the Vermont Center on Behavior and Health. And I want to welcome those of you who are here in person and those who are streaming with us this morning. So first, a couple housekeeping matters. This is the last lecture in the fall series, but we will pick up again in the spring semester, starting on January the 15th, when Rick Rawson, one of our own here at the VCBH, will be presenting, I'm guessing on contingency management, but I don't know exactly the title yet. But today I do know who we have, and I'm really thrilled that we do, that Hugh Garavan is with us. Hugh is a cognitive neuroscientist and a professor in the Department of Psychiatry here at the University of Vermont, and truly a international scholar who is widely recognized globally for his contributions, largely in the cognitive neuroscience of addiction. And Hugh did his BA training, and this is a little bit how he has this global impact in his work. He's trained globally. He did his bachelor's work at the National University of Ireland, then on to Bowling Green here in Ohio in the United States, where he did his doctoral training. He did a postdoc at Cornell University and another at the University of Wisconsin in Madison. He then went back to Ireland, where he took a faculty position in cognitive neuroscience at Trinity College, a really long-standing and well-regarded university in Ireland. And he was there from assistant through associate professorship in 2010, and then came to UVM in 2011, and it's really been a great addition to our university. Hugh has more than 450 peer-reviewed publications on various aspects of the neurobiology of addiction. His work has been cited almost 50,000 times, highly accomplished in grantsmanship and obtaining external grant support. And a couple that really stand out for me is he has an important role in the National Institute on Drug Abuse's ABCD and HBCD longitudinal studies of brain development and addiction risk. So Hugh, thanks for being with us, and I'll turn it over to you.
Thank you. That's great. Thank you so much. I'm delighted to be here. The last of the season, huh? So keep the best to last. Is that what you meant to say? Or something like that. Okay, so I'm going to chat about the ABCD study. So a little bit of background. I'm just going to give you an update of where it's at. And it's actually at an interesting juncture, as you're saying. We're in the process of designing ABCD 2.0. But we'll start to just go through this, and obviously happy to take questions at the end. So in essence, it's a longitudinal study of about 12,000 kids, all of them recruited at ages 9 and 10. Vermont here is one of the recruitment sites. There's also by design a twins component. So as you'll see, there are about 2,100 twins, and not by design, but just by happy circumstance, we have 30 sets of triplets. And I have no idea what the research question is, but somebody should do something with the 30 sets of triplets, right? And, very extensive assessments, and I'll get into that just a little bit. But also kind of what's we think is kind of, great is that the data are publicly available. So once we analyze it and process it and de-identify it and people become registered users, anybody anywhere can access these data, which we think is kind of great. And there's details there on the website. Just that's it again, showing you the different sites. A lot of time and effort was put into the recruitment. It was all done through schools. It was sort of, to call it representative is dangerous, because representative means very specific things to the epidemiology world, but it's at least a diverse sample. Which is good. You notice that we're at a bunch of different sites, and I don't know if that's going to prove to be consequential, but just given the time of year, I did decide to look at differences across our sites. So this is how much sunlight each gets. You never guess where Vermont sits relative to all the others. And then one more, the daily temperature. And again, you never guess where Vermont is. I don't know if this is going to prove consequential in adolescent development, but you don't know. We also have kind of fun ones about how much sleep, and we also score very highly on that. And these might be related, but who knows? So again, extensive assessments. I mean, the kids at baseline come in, and at 9 and 10, they give us about 8 hours of their lives. So I think, really heroic efforts by them and also by their caregiver who, did about 3 or 4 hours of assessment. So this is heavily biased towards brain imaging. So there's a big neuroimaging component, but also it's a lot of things you might imagine, lots of cognitive assessments, personality assessments, mental health assessments, but also, substance use, culture and environment, family history, physical health. We take bloods, we take saliva samples. So there's a whole biospecimens. We also take their current address, and there's kind of great data sets out there, great databases, so we can link our individuals to all sorts of interesting environmental measures. So, you can get databases about, the proximity to grass, to, air quality, crime statistics, nearest liquor stores, things like that. So it's a very extensive data set. I think at baseline, even if you exclude all the imaging and the genetics and the geolocation stuff, there's something like 60,000 variables per participant. So it's a big, huge data set. And then we have assessments essentially annually. And we've been doing that for many years now. So it's a big, big data set, which raises all sorts of interesting challenges, opportunities, but challenges. We also have, this all happened during COVID. Not great thing to happen in the middle of a single cohort longitudinal study, but there you go. So we had some COVID assessments. Just here in Vermont, so the recruitment started on October 1st back in 2016 and finished about 2 years later. We recruited about 580 families. This was a real challenge. I should mention my co-PI in all of this is Alexi Potter. When we were looking across the different sites, like LA had to recruit a certain number. Like for Vermont, I think we had to recruit pretty much all the 9 and 10-year-olds in the state, or at least in the county, to hit our numbers. But we did it. I don't think we actually thought that we could. Of course, we didn't say that in the grant application, but when it happened, it was a busy couple of years. That's kind of all the data collection now over the different years for the Vermont site. So you'll see there's lots and lots of data collection. I think in total, this is about a month old, but about 6,500 in-person assessments have been done here thus far. And we have very, very high retention. Now that's probably a little bit skewed. So these are, 7% have formally withdrawn, saying, don't contact me. There's a lot of sort of de facto withdrawals, people who just have missed the last couple of years, but we don't give up on them. For a longitudinal study, if we have your data at 9 and 10, and even if we just get one more data point at age 20, that's still super valuable. So we do all our best to stay in contact with all the participants. And then across the full study, that's what it looks like. So yeah, about 136,000 assessments thus far. So it's a big endeavor. It's a costly endeavor. But yeah, we enjoy it. It's a great consortium. It's very interesting. It raises all sorts of interesting opportunities. We'll talk a little bit about this in terms of, big data and the needs for large sample sizes. So that's the study kind of in a heartbeat. That's what's ongoing. That's what's been happening thus far. That's what brings us here. What I want to talk about, so it's a little bit about just, has it had any impact? So somewhat controversial study, right? Because a lot of money and resources went into this one study. And a lot of people say, gosh, is that worth the equivalent number of R01s you could have funded? So obviously we're very attentive to, has it been impactful? A little bit about scientific findings. That's a tough one to summarize. So I've just kind of cherry picked a few things that we can talk about, and then we'll finish up with some future directions. Okay. All righty. So let's start off with impact. So lots of papers. So, we're now in, year 6, 7 of data collection. So there's been about, 1,300 papers have been published, which we think is kind of great. And I think that's just a testament to the open science model. And people look at this and look at impact factors and things like that. And actually they tend to score on average pretty highly. I think, I was fearful that there'd just be thousands of papers on small little pieces and parts, but it seems like that's not the case. It's open science. There's over 8,000 registered users around the world. The other thing that's interesting is that it's generated lots of grants. So there's a lot of grants out there, let's say K awards or, miscellaneous training grants or just research grants to conduct analysis with this large data set. So it's actually generated a lot of funding. It's also, I think, had a significant impact on how science is done. I don't overstate this, but our data sharing model, it's an interesting, for people who've been around for a while, there's been a really interesting evolution in our field. I've been involved in other longitudinal studies, so one in Europe that started about 12 years ago, and there the data sharing is not as good. There's this sort of sense, well, we collected the data, so we should have first dibs before we make it available. But the culture now, I think, has very much shifted that, and it's even required now by the NIH. We're giving you money to collect data, you must share it. And I think that, ABCD has just one example of how this can be done and can be done well. So I think it's just certainly amongst the younger investigators, it's now just the norm. People just assume all data should be, not that I have to share, but actually it should be shared. It's better to share it. And also I think a lot of impact on the necessity, I'm going to say, for large samples. I won't talk about this at length, but you might know, like in the world of neuroimaging, there's been a lot of anxiety over the last few years that most of the studies are not reliable. Sample sizes are far too small. There's a high impact paper that said you need thousands of participants if you really want to find brain behavior associations. And I think a lot of these insights are coming from studies like ABCD, where now people have large sample sizes and can, detect effects and do proper cross-validation and establish, okay, this is reliable. And what we're finding is that effects that are reliable tend to be very, very small. I should have actually prepared a slide on this, but I'll just mention one more thing on this topic because it's kind of interesting. I had a postdoc, Max Owens, who was interested in this question about effect sizes. And he grabbed about 200 just, psychological measures from the ABCD sample, sleep quality, mental health syndromes, neurocognition, things like that, and just correlated everything with everything, just to see. And the median, and most of them were kind of like sensible, things that you might expect to be related to one another. So across all those thousands of correlations, the median correlation was 0.03. And if you do Bonferroni correction, if you add covariates, it doesn't really change much. I think the 99th percentile was like maybe 0.07, 0.09. So in our world now, if we relate brain to behavior and we explain 1% of the variance, we consider that a victory. We think that's big. And so that's kind of an interesting thing to start to think about. Well, was it worth all the money to explain 1% of the variance? Is that meaningful? What's a clinically meaningful effect? So there's a lot of issues, I think, just about science, how we do it, what these numbers actually mean that have kind of come from working with these large data sets. And then you mentioned the HGCD study. I'll finish up with that a little bit. I think ABC having been successful has kind of given confidence that other similar studies might be viable. Okay. So keep going with just impact. Just for those of you who care, this sort of gives you a sense of what the topics are for the papers that have been published. You'll see there in kind of the word cloud, brain structure, early adolescence, obviously, ADHD, and so on and so forth. And then for those who are interested in mental health conditions, that's kind of a ranking of what the topics are that investigators have published on in those 1,300 papers. The other thing, I just maybe it's on this slide or the next slide, at the beginning, most of the papers were coming from within the consortium, but that's completely flipped in the last couple of years. So now it's mostly from outside, which we see as a mark of success. Sorry, this is a bit detailed, but just again, if you're curious, the papers were categorized about what's the primary focus. So the main focus of, 604 of the papers is on mental health. And then what you're seeing below that is just then the breakdown of kind of, secondary foci. So of those 604 papers, you'll see the gray bar is big. They include, a substantial kind of neuroimaging focus. Just give you the sense what the user community is doing with these data. So mental health, neuroimaging, physical health, neurocognition, and so on and so forth are the primary foci for investigators. Okay. If anybody had, I don't know how you normally work this, but I'm happy taking questions if there's anything you want to just clarification on as we're going along. Lots of grants have been funded. These are the institutes that are doing most of the funding of those grants, even though NIDA was the big driver of the project initially, it's actually the NIMH that has been funding most of these add-on grants, these add-on research questions. Okay, all right, so that's a little bit about the impact. So scientific findings. So I think we're doing okay on time. I was fearful I had far too many slides, but as is usually the case, I'm rushing as I'm speaking, so I'll try to slow down a little bit. So this is a toughie, given that we have, 1,300 papers. Obviously, a primary focus is brain development, right? So again, I didn't really give this by way of background, but you probably know this, like adolescence. Let me just put this in context. I think you all know this, but we'll say it anyway. Is a significant period of development, right? Consider a 10-year-old to a 20-year-old, interests, academic achievement, onset of mental health issues, neuroplasticity. A substantial amount happens during those 10 years. So that's kind of a primary focus here. So we're interested in brain development. This is just one of our participants. You'll see scanned at age, just, the baseline 9 and 10, 2 years later, 2 years after that. One thing you'll see if you look at that is that the brain changes, they're not especially dramatic, right? I mean, in terms of brain structure, you're not seeing huge changes during this period. How do we go about measuring this? Just to give you an example, you might be aware of this, but it can be useful to, give a little bit of context. So typically, we get a brain image like this. This is kind of a standard structural anatomical scan. There's miscellaneous processing that'll, kind of clean it up, correct any head motion, remove the skull, identify just the brain. You can zoom in and you can kind of trace the outer boundary and the inner boundary of the gray matter. And then you can measure the thickness of cortex. And cortical thickness is a very interesting and useful brain measure. If this looks like good old-fashioned phrenology, it is. Phrenology was a great idea, except for the fact that they thought that skulls told you something about brains, which they don't. But actually measuring cortical thickness is a really interesting phenotype. You probably all know, the London taxi drivers with their larger hippocampi, but, it's flexible. If any of you have, I don't know, if you play a musical instrument, you got fine motor control, the brain areas that are involved in motor control of your fingers will literally be thicker. If you have perfect pitch, temporal pole areas will be thicker. If you learn to juggle, you can actually see increases in the thickness of your cortex. If you stop juggling and you lose the skill, it'll go back to where it was. So, the gray matter is kind of dynamic and does reflect, individual differences, individual abilities. It's nuanced. So we've just been doing this in the last while. So this might seem really like a bit too much information, but we were just curious. This is literally just brain cortical thickness. We divide the brain region into about 100 different regions of interest, and we get the average cortical thickness. I don't know if you can see the scale there, but it ranges from 0 to 3.5 millimeters. 9 years later, it still varies from 0 to 3.5 millimeters. On average, the cortical thinning, so this is typical. So neurotypical during adolescence is this pruning process where you lose synapses. So, you kind of, as you develop, you got like, lots of connectivity to, all across different brain systems, and then systems that are needed, that are used, become strengthened by pruning away ones that aren't. So cortical thinning is kind of neurotypical. But just to kind of quantify that, the amount of cortical thinning is, across these regions is between 0.05 and 0.2 millimeters. So like, it's really, really small. And then we're trying to chase whether or not that there might be individual differences in that thickness, or that thinning might be impacted by poor sleep or good nutrition or physical activity or substance use. So, we are chasing small effects here. Just kind of, put the problem, the challenge into context for you. Okay. As Steve mentioned, my background is actually in cognitive psychology. So brain structure is interesting, but I'm personally much more interested in brain function. So obviously we've got a whole slew of tasks that measured that as well. So we can measure brain activity as the participants are doing tasks. So we can measure a working memory task. We can measure a sort of an impulse inhibitory control task, and we can measure reward processing. And these were chosen because we thought these might make for interesting brain measures. Both these might show interesting development. Yeah, reward processing, how you process rewards between a 10-year-old, a 14-year-old, you cross over puberty, a 20-year-old, that might evolve in interesting ways. Impulse control similarly. And, the hope is that might be related to things like, psychopathology or risk for psychopathology, or does impulse control change if you start using alcohol heavily during your adolescence, or is it predictive of some mental health outcome? These are the questions that are motivating it. That's maybe clear, but again, just to be, I guess, super, super explicit about it, the real benefit of this study, I think, is yet to come. So the point here, and again, maybe it's obvious, but we'll just say it, these kids, we have 12,000. So some percentage of them are going to do great, right? Some percentage will develop psychosis. Some will develop depression, anxiety. Some will attempt suicide. Some will be successful, in committing suicide. Once we have those outcomes, and maybe that emerges at ages, 17, 18, 19, 20, we will have 10 years of longitudinal data. So we will be able to go back and say, well, what was the trajectory of that kid who developed psychosis versus who did not develop psychosis? Do we have any hint? Is it in the genetics? Is it in the family? Is it in the exposures? Is it in brain development that identifies who was at risk, who was vulnerable? What changed with the onset of that mental health illness? And when you have 12,000 people, then you can start to ask a more nuanced question, right? Well, what if it's the kids who had some early trauma, or have this, polygenic risk score 4, or who live in this not so great environment? Or does it differ between males and females, or across races and ethnicities? So you see, as you start to ask those questions, that's why 12,000 quickly becomes a lot smaller. And that's kind of the motivation for having a large sample. So that's kind of where we're at. And like, the fun stuff is starting to come, because now the kids, our next data release will be in January, and there'll be 4 time points. So brain at age, if you will, 10, 12, 14, and 16. So 4 data points. So now we can really start to, map trajectories, and now we're starting to see, again, these mental health, symptoms, these start to emerge, including diagnoses. And then not just mental health, but just also these kids who do well at school, like, what have they got, and what does that do for them? And, is their brain development, you can start to imagine the questions. Is their brain development related to the quality of their sleep, quality of their nutrition, mindfulness in school, playing sports, and on and on and on and on. And that's why when you start to think about it, it makes perfect sense to say, we can't handle this. Let's just make this open science and let the community come at it with all the different questions that they have. Okay. So yeah, and these slides aren't the most interesting, but just to let you know that, like, right now we're in the thick of trying to study these brain changes as a function of age. And you'll see, you need to kind of steer, but we're obviously doing this in a more quantitative way, looking at developmental trajectories, brain region by brain region, as working memory improves, as inhibitory control improves, and also, then as reward processing measures change. So again, this is kind of like the ongoing research now that we're trying to focus on. Okay, so that's brain development. But for the most part, and again, maybe speaking as a psychologist, many of us are only care about brain development insofar as it tells us interesting things about things like mental health and cognition, right? So, we have these cognitive scores. This is just to give you a quick flavor. Cognitive abilities are also increasing, as you might imagine. These are a bunch of tasks from the NIH toolbox. Mental health, for the most part, is, decreasing with age, but you'll see there, the exception might be internalizing symptoms in girls, in females. That's not showing the same pattern. But again, underneath each of these curves, there's a whole slew of individual differences, a whole slew of different trajectories, which we're curious about. Of course, then the next thing that we're interested in is not just brain development, mental health, and cognition, but what influences all of that, right? And we've already kind of alluded to a number of them. A few caveats, because I'm going to start now talking about some of the scientific findings. This is maybe obvious for, for the present audience, but it kind of has to be repeated. Even in this big, expensive, longitudinal study, it's still fundamentally correlational research, right? It's really hard to assert causation from this study. Even if we have temporal ordering, I think we can get closer, and there's a few strategies that we can get at. So, let's say screen media activity, if that's an interest. And actually, just as an aside, it is. When we present this to parents, it's really interesting. I mean, I don't know, 10, 15 years ago, if you were to give a talk about adolescent development, I think one of the first questions you could ask is, well, what do drugs do to my kid? And what does cannabis do or alcohol? Now, first question, screen media activity. What do phones do to my child? So we might find all sorts of associations between screen media activity and its anxiety and depression. But again, causation really hard. Now, the longitudinal data helps because if we find, an increase in screen media activity that precedes the anxiety, maybe, but it's still inferential. We still really don't know. There might be, a third variable. You don't really know. Like I said, there are things we can do, and I might allude to a couple of them as we go along to maybe try to sort of get a little bit at causal statements. But yeah, results are still at the group level. We spend a lot of time trying to create these kind of, brain-based classifiers. I think we're getting better at being able to make predictions about individuals. But for the most part, everything we're talking about here is still group-based. We are not at the point where we can look at a brain and say much of anything, right? And I think I already said this. I think the most interesting science is yet to come now that we get more and more of these longitudinal trajectories and these developmental curves. What I'm going to focus on, I don't have much to say about happiness, just one slide, because, being psychologists, we don't study things like happiness, right? So that's why I thought I would include it anyway, just to let you know that some people study things like happiness. But we'll talk a little bit about screen media activity, a little bit about sleep, some pandemic effects and health disparities and anti-poverty programs. Again, with 1,300 papers, it's really hard to know where to go with this. All those papers, by the way, are on our website. And it's pretty good, it's searchable. So if you're kind of curious about, a particular topic of interest to you, you can go there and do your search. Okay, this is kind of busy. I'm not, between you and me, I'm not, it is what it is. It's just one quick study that I came across. They looked at a whole bunch of different measures. They're essentially interested in just positive affect and, in measuring in a very particular way, just with those sort of questions in the bottom right there. So you can decide yourself if you think that's a meaningful outcome measure. But they were trying to look at a whole bunch of different measures and what sort of measures co-vary together, hence this kind of, network analysis, and find that generally, the domains that related to positive affect were these things like, behavioral dysregulation, cognitive functioning, psychological problems, supportive social environment, extracurricular activities. And across the different ages, the only one that kind of came through repeatedly was the supportive social environment. So again, I don't think this is going to light the world on fire, but just to let you know that some people are quite interested in these sorts of outcomes, resilience, grit, how do you build a happy kid? So it's kind of an important topic. So people are looking into it. Screen media activity is a big one. So I'm going to belabor this a little bit because again, it's what we get asked the most. And it's complicated, as you might imagine. So a little bit of information. So how much time, are kids spending each week on screen media activity? And we can break that down. And there's probably different ways you can break it down, but it's a broad topic. There's the active, gaming, multiplayer, single gaming. There's just kind of passive watching TVs, movies. And then there's mixed where you're texting and video chatting, the kind of social stuff. So, those are the numbers. Sorry, it's a bit busy, but sort of giving you the distribution. The first one there is at, does it say it? Yeah, ages 9 and 10. You'll see, sorry, it's a busy slide. So I'll give you a second to orient yourself to it. But on average, between ages 9 and 10, our participants are spending, about 6.5 hours doing, so that's, an hour a week roughly, doing the sort of active media, video gaming type of stuff. But they're also doing 14 hours of the sort of passive TVs, movies, and about 3 hours of this, texting and so on and so forth. You'll see 2 years later, those numbers have all increased pretty appreciably. So, I think you all know this. If you have kids in this age range, that, they are surgically attached to their phones. We can break that down a little bit. This is another way to look at it. We have a sort of more objective measure. So a lot of these things are based on self-reports from the kid, from the parents, but we have a way that, we can install an app on their phone and we can actually count keystrokes and the amount of app use. And this is showing you the amount of app use across a 24-hour cycle. And a few take homes from it is that these participants are now age 14 they recorded an average of 5 hours. This is just the average. So 5 hours of daily smartphone use at 14. And that, which is kind of interesting, is 2 more hours than they self-report, right? And I don't have this information, but I'm going to guess, and that's probably like another hour more than their parents think they're using. Females are logging more smartphone use than males. Smartphone use was recorded at all hours, and you'll see they're peaking from 8 to 10 in the evening, lows from 3 to 5 a.m. Social media, texting apps comprise nearly half of the use. This I found really kind of fascinating. A full 80% of our participants, use the app between midnight and 5 a.m. And that's defined as at least 1 minute of app use per night. So, there's a lot of screen media activity, a lot of smartphone use. If you're interested, again, it's a bit busy, but it just sort of breaks down what they're doing as best we can tell. One of the challenges here for like the games and the video streaming is we don't have a good handle on what types of games they're playing. And that's obviously a big one. Is it violent games or not? This gives you the breakdown of what they're doing. This is just another way of what are the primary apps. I think this is maybe a good way to show your age. How many of these can you actually identify, right? I might know, I don't know, 5 or 6 of them. I suspect, a 14-year-old I know all of them. It's probably like an interesting test of chronological age. But so that's what they're using. Now we start to look at kind of, the big question that people want to know. And there's nothing too surprising in here. I'll just jump right to the punchline. Yes, more screen media activity, more mental health. Again, but with that caveat about correlation rather than causation. So something went wrong a little bit in the formatting, but if you can see there, it's sort of like just an odds ratio. So the more social media time spent, you'll see there, just kind of to the right of the vertical line for 1, you'll see kind of slightly higher odds ratios for externalizing problems, for, they're sort of falling off the line, but but sleep issues and, problems with peer relationships. I don't think there's anything striking here. I think these sort of associations, where I think people are aware that these associations are there. Messaging, communications, so that kind of texting, more of the social media stuff. Again, you'll see all to the right. Video streaming, a few more hits. The one that's kind of different, bottom left, is the number of close friends is lower as a function of more time spent doing video streaming, and then just other categories. So, again, this has been established. There's nothing new. So our sample is kind of representative in the sense that they're showing these patterns. Now, there is another way to come at this, another type of question. So video gaming, if you can remember this is what I think about when I think about video gaming. But of course, video gaming has gone way more complicated. And, apart from potentially being kind of gruesome, they're also really cognitively challenging, right? If you've ever seen somebody do these things, I mean, it's an extraordinary amount of visual information processing and hand-eye motor coordination and so on and so forth. So, one question one could ask is, might there actually be some benefits associated with video gaming? Maybe it depends on the amount of time spent gaming. Is there some happy number? These are the sort of questions, just to step back, that kind of motivates the study. So we can study this. Can we come up with like an answer to that question? Does the amount of time, is that consequential? Because maybe that might help inform policy. Okay, so what we found, now I will point out, this was done by my colleague Badr Chorani in psychiatry. He himself is an avid video gamer. So there may be all sorts of biases hidden throughout here, but parking that, what he actually found is that for those who were gaming, and you'll see there, less than an hour and 1 to 2 hours, 3 hours, and up, he says actually better accuracy on some of our working memory tasks. And that's actually related to, increased levels of brain activity. When we look at some of the mental health associations, it's kind of an interesting story. If you can just zero in on one of those graphs, you'll see that the never gamers, those who have gamed less than 1 hour, don't show elevated, again, it's all correlational. They don't show, elevated levels of these, thought problems, attention problems, or internalizing problems. As you go to higher levels of video gaming, you do see that. But the ones who are showing, who are reporting just kind of 1 hour in video gaming, are showing improved, this is just mental health. Yes, right, you'll see here the mental health. So in some cases, actually showing lower levels of mental health symptoms. I'm not necessarily sure why that would be. You could probably start to imagine yourself, what might be driving that. But the thing I did want to mention is that they are showing a number of cognitive benefits, if you will. So there might seem to be a happy medium, if just kind of, I know this is a busy slide, kind of putting it all together, high levels of video gaming, are related to, associations with mental health problems and few of the cognitive benefits. But in this happy zone of less than 1 hour a day, you're actually seeing none of those mental health correlations, but you are seeing improved cognitive scores. Okay, again, one has to be cautious about causation, but at least that's what the data are suggesting to us. One way we can come at this, and I sort of perhaps this a little bit, we do have this kind of fantastic resource. We got 2,100 twins in the study. So, and this is one way that you can maybe kind of get maybe a hint at causation, is the twin discordance approach. So if you have twins who are, in this case, monozygotic twins, so let's say genetically almost identical, probably identical, well, yeah, genetic identical, brain at birth, pretty much identical, home environment, et cetera, socioeconomic, blah, blah, pretty much identical, but they vary in how much gaming they engage in. If that's discrepancy, that discordance is related to discordance on some mental health score or a cognitive score, whatever, you can maybe say, well, gosh, maybe it is the gaming that's kind of the important, critical factor. Again, it's an imperfect inference, but it gets you maybe a little bit closer. And so Badr is seeing this. And I don't have it here, but what Nick just reported is that twins who are discordant, this is gaming, but twins who are discordant on the social media activity, the texting and so on and so forth, the stuff that people are anxious about for, bullying and all that, if that level of discordance is actually related to discordance on a depression diagnosis. So again, it's not causation, but it's getting closer, maybe. So these are the sort of strategies we're trying to engage in a lot. And I think this is actually important. To my knowledge, this hasn't been done. There's a boatload of correlational studies, but anything that kind of suggests there might be some sort of causation here, I think this might be one of the first. But, we will let the reviewers decide if that's a true statement. We can look at sleep. So sort of different topic. Another way to maybe get at causation, ish, is by exploiting the longitudinal data. So this is a bit busy, but, just to unpack it a little bit, what we have here are, so the DIMS measures just, difficulties initiating and maintaining sleep. So as you might imagine, if you kind of go across the top row, those difficulties maintaining sleep at 9 and 10 will be correlated to 10 and 11, to 12 and 13, and so on and so forth, right? And they might also be correlated in one point in time. If you look at a column, really it might be related to externalizing and internalizing. But what you can do in these sorts of analyses is see, well, is problem sleeping at ages 9 and 10 related to internalizing problems 2 years later? Or is it the other way around, right? So it's another way to try to see, can we get a handle on, again, a probable causal direction just by exploiting the kind of temporal ordering in which these things change, if that makes sense. So these kind of cross-like correlations. And here you see like it's busy. The difficulties initiating sleep at 9 and 10 is related to internalizing problems 2 years later, but internalizing problems at 9 and 10 is also related to, problem sleeping 2 years later. So it's not a simple story. But, so you have that. And again, we have it looking at sleep duration. So again, so there are these associations, and like I say, trying to unpack them is what we're, trying to do. And I think here, I'll not put kind of a definitive interpretation on this. You can kind of read the connections for yourself and draw your own conclusions, but more just to flag as a methodology. This is what people are doing to try to get a handle on these questions. Okay, we are making good progress. I don't have a lot to say about the pandemic, other than the fact that it completely messed with us. But so we had to, we missed. It was actually, just as an aside, it was really frustrating because a lot of our kids were just entering into that puberty period, right, where stuff is really interesting and where we really wanted to get biosamples and brain imaging. But of course, that required an in-person visit, which we didn't have on a substantial number of them. But we've moved to kind of remote assessments pretty quickly. There's a lot of papers on pandemic effects. This is just one, and it's kind of busy, but just again, by way of example, what, kind of the take-home message here is that, just somebody was interested in, if you can see on the y-axis, things like family stress and discord, or parents' stress over the pandemic, and showing that the amount of stress was related both to, how potentially disadvantaged the family was, so material hardship, that's in red versus not in blue, and then also, with alcohol use. So you'll see, more hardship, more alcohol use, greater stress, greater family discord. So, the take-home message from this and a few related studies is that families did best if over the pandemic there wasn't an increase in parental alcohol use, if there were fewer disruptions to social support and routines, if people made time to relax and exercise, if there were fewer pre-pandemic psychosocial and financial vulnerabilities, and little pandemic-related financial insecurity. So, again, probably nothing too controversial in that, but, these are the data. What we haven't looked at is, well, no, I shouldn't say that. Others have looked at other mental health, et cetera, outcomes in the participants. I don't have a great feel for that. I find myself unable to do research with the pandemic. I just want to forget about it as soon as possible. So, each to their own. We're getting there. Actually, this is the last example of the science. This again is a little bit busy, but it's kind of an interesting approach. So the study, wasn't really designed with a focus on health disparities, but there's a really big group of people who are interested in that question. So we have 12,000 kids, so they do vary in socioeconomics, but also what's kind of interesting is they also vary in state and state legislation. So people like our colleague here, Alexi Potter, who's interested in gender identity, gender minority groups, different states score differently in what sort of legislation they have that's either punitive or protective of gender identities. Different states differ in their in the legalization of, let's say, marijuana. And so we can kind of look at a state level, do those things have an impact? So, it's kind of interesting. Like, it's not perfect. We got just 21 sites and not 21 states because there's a few sites in the same state. But, people are looking at it. So this is kind of busy. But basically what it's showing is that, you won't be surprised. Across multiple measures, including brain measures and things like hippocampal volume, if you look at, lower income families versus higher income families, you will see brain differences. You'll see education differences, all sorts of, mental health differences. But what we find looking across states, that effect can be, greatly diminished as a function of the sort of state-based supports that there are for lower income families. So it's an interesting one, and it's, it's very indirect, state level is a kind of coarse way to do an analysis. For Vermont, all our 580 kids will get treated, as being affected by the state legislation. But it's an interesting approach to try to see what sort of development and changes might emerge as a function. And especially, just as an aside, for those who are in substance use, to have this interesting cohort where different states cannabis is or is not becoming legal at different time points or different points in their age. So, you imagine it gets a bit busy, but it's an interesting kind of natural experiment to maybe see how those state level policy-wide changes might impact on mental health, cognition, and so on and so forth. Okay, good. Good. So last couple of slides. So a few future directions. So, obviously dissemination is important. This is, the NIH has put a lot of resources into this, so they're kind of keen to make sure that the findings have an impact. They measure all these metrics, not just of publications, but also kind of social media uses of references to the study. That seems to be all going pretty well. We try to create these, kind of easy to digest infographics about what the study is finding, so we can share that with our participants, and we can share it with politicians. Obviously there's anxiety as to what's going to happen in the funding landscape, and we want to, make sure that the study keeps going. So we want to keep conveying, what's being found in the study. There's a lot to do. And then this is just going to let me transition to like last slides, maybe last two slides, just to let you know about the HBCD study, right? We do love our acronyms. So ABCD, kids at 9 and 10 followed until ages 20. HBCD is similar, but we're going to recruit about 7,500 pregnant women and follow them and their newborns up until age 10, with the idea then it might kind of stitch together with the ABCD sample. So that's ongoing across 25 sites in the US. This one is sort of a overrepresentation of substance using women during pregnancy. A lot of this is funded by the HEAL initiative. That's why it's in the title there. So this kind of, opiate funding. So to see what are the short-term and long-term consequences of in utero exposure and try to disentangle that from maybe, the child rearing. There's the usual battery of assessments, all the things you might imagine, biospecimens, MRI. We get our first scan on the infants within the first month of life. And again, open science, our first data release for this is also in January, and I think it'll be about, maybe 1,500 participants in that. So a database of about 1,500, neonatal brain scans, EEG, wearable sensors, behavioral assessments, and so on and so forth. I think, so UVM is one of the very few places that is running both the ABCD and the HBCD, and I think this sounds self-congratulatory, but why not? I think Alexia and myself are the only PIs on both. So this is great, and this keeps us very, very busy, as you might imagine. That's just more of the same, really just telling you about the study. And finally, as I just mentioned at the very beginning, we're now in the process of designing ABCD 2.0. So obviously we want to keep this cohort, followed. What ABCD 2.0 will look like as the kids are in ages 20 to 30, we actually don't know. We're really kind of thinking through it. Do we need brain scans every 2 years? Probably not. What are the important outcome measures? I think a big focus will be just kind of health outcomes, or maybe health-related behaviors. But there's all sorts of interesting developmental things, first jobs, relationships, post-high school training, be it, universities or whatever. So we're literally like in the process right now of trying to think through what that might look like and what will be included. But again, that's where I think, again, these outcomes, once we have those, and these are kind of only temporary outcomes, because of course there will be an ABCD 3.0 and 4.0, we hope, right? But that's where then like having this rich data during the adolescent period, I think will become more and more interesting when we get these more and more interesting, outcome measures, if you will. Done. Thank you.
Chris, either of these? Hugh, thank you for really a very stimulating, interesting talk. So it's open. We have about 10 minutes for Q&A, and those who are streaming, send in your questions. So do we have one from the in-person team? Yeah, we have one over there. Here. And use the mic so people stream.
Thank you. It's great to hear about this longitudinal work, and I understand what you said about really looking at these correlations more than individual differences, which is what I'm really interested in. But I'm wondering if you've been able to see some kinds of markers of certain stages of development because of this longitudinal look that you have. And what I'm really thinking about then, is there a way that you can assess that, how a different kind of biological age in some way might differ from someone's chronological age, and be able to sort of analyze the data differently to see about how it's aligning with certain markers of development, stages of development?
So markers I'm not so sure about, because I'm trying to think like what would be a marker. Like in the HBCD study, you might have first words or, first time walking. In the adolescent period, I'm not sure what would be a discrete marker, unless you have some suggestions. But
no, I'm thinking about the cortical thickness is an example that you measured. Is there an expected place that most people are at a certain age, but
right,
then
yeah.
some people deviate from that, and maybe
Yeah.
they're at a different stage in development, earlier or later.
Yeah. So the marker I'm not so sure about, but that's sort of the brain age gap that you're talking about. Absolutely. So this is the beauty of having 12,000. You can actually get, if you will, normative developmental charts, and then we can quantify each individual. So at age 13, the big average is here, and how discrepant are you from that? And those markers, this has been done a lot, seems to be related to a whole slew of psychopathology measures. So yeah, that people are already starting to look at that. And it's an interesting way, I think this is what you're getting at too, of measuring brain, not just your cortical thickness, but your departure from what you should be at that age range. That tends to be more sensitive for a lot of analyses. So absolutely, that's available. Yeah.
Nice, thank you.
Yeah.
Thanks for a great talk. Really just exciting work every time I hear about these studies. I have one very practical question and then one more out there question. But the practical question is for faculty, trainees, people who want to gain experience with these data sets. Can you say a little bit about how you might learn to work with these large data sets, or access people who already know how to work with those data sets?
That's a really good question. We actually do provide a training ourselves, but this is a very specific thing that we provide for underrepresented minority scholars, and we give them like a whole year of mentorship. To my knowledge, there are no, that's not true. There's a thing called ReproNIM, where they have, and they do this every year, and they also, so it's a training course, it's a lecture course, and it's a hands-on active data analysis course. And they've all those lectures, I know I kind of contributed one, are available online. So it's a whole kind of training in how to understand the study and actually how to optimally analyze it. So that's called ReproNIM, and I can point you at that. In terms of hands-on training courses, we used to do these at the beginning, trying to kind of drum up support like at conferences and things, but we haven't done that in a while. We might start, this is a longer answer than you wanted, but we are now in the process of building a kind of a portal to analyze the data that would hopefully user-friendly. One of the challenges is that we have this great data set and it's yours, except it's too big for you to do anything with, right? I mean, it's huge. You can't possibly, unless you're, a handful of labs in the world, you can't possibly download it all. So we're creating a portal that has a nice, really, data dictionary, has all sorts of explanations that will actually let you set up an analytic model. Baked into it is the optimal analysis methods, queries you on covariates, and actually runs it for you. And it all happens up in the cloud. And that will probably have some built-in tutorials with it. So that's a kind of a second option.
That's good to know. Thanks.
Okay. Now you have a more difficult question.
Well, this is just an out there question. You had me thinking about policy and all the really interesting questions you could ask, differences between states. Do you have measurements on political leanings or family, voting Republican versus Democrat, or beliefs about the world?
We don't have Republican versus Democrat, which is maybe a good thing. I'm not sure.
For funding, it is.
Yeah, it depends. We do have things, this isn't really, there are some measures on this. So we have questions to kids, especially during COVID, were they participating in any protests? Because it was also the time of the George Floyd. We have questions, in the family and culture about like religiosity and practice and extracurricular activities. So we have those types of measures. I'm not sure that's exactly what you're getting at, but it gets close. It's very hard to know off the top of your head what exactly is there, but there are, if you have a specific question, we could chat about it.
Hi, so loud. Great talk. I was wondering, because I know you were saying there's a lot of questions from parents about screen time and phone use. I was wondering if using your ABCD data sets, if there's been any sort of analysis or examination of maybe protective factors against a lot of screen use within your data set or within these participants, and what those types of like mediating factors or protective factors might look like if your study is examined anything.
It's a really good question. I can't answer the particulars, but you ask, even to unpack your question a bit more, one of the challenges with screen media activity, too much time on TV, increased mental health, is that, if you're spending too much time on TV or on your screens, are you getting less sleep? Are you getting less physical activity? Does it say anything about your family environment that you're being allowed to do this for 10 hours a day? So it's really, really hard to narrow it down that it's really the screen activity per se. But then that opens up the question that you're asking about, like if you're doing 4 hours of screen media activity, but you're also getting physical activity and you're also engaging in these other extracurricular activities, maybe you don't see those elevations, right? So people are absolutely looking into this question. And I think the primary, kind of protective factors that people will look at will be things like that: nutrition, sleep, physical activity, but then also, we have all sorts of measures about, parental monitoring, peer supports, numbers of friends. So all of these things could potentially be incorporated into the analysis to see, do they have a moderating effect, or do they fully protect you? And I think it's a really interesting question, because if they do, that's great, right? So then you can really start to give empirically based research as to what are the dangers, but what you can do to ameliorate the dangers. But I just don't know what exactly the take-home message is as yet from that literature. Yeah, but it's doable. It's a somewhat viable question now.
Okay, we have a couple questions from online. Jazzajid actually just said that this was a phenomenal talk. Thank you very much.
Let's
And
just stop right there then, shall we?
offered just a cautionary words about the correlational nature of longitudinal studies. There was an anonymous question, particularly with neuroimaging analysis. What are the best practices for handling large effects of background variables, such as social determinants of health and environmental factors that may be larger than the effects that we're interested in?
Yeah, so that's a really good question. And that starts to even become a somewhat controversial question as to what you should control for and what you shouldn't. It's also how to put this in shape. This is one of those kind of meta-scientific questions that we're really challenged with. And it kind of comes back to your question as well. So if true effects are small effects, if you just assert that, and let's say screen media activity, doesn't matter, but there's no effect where we have a relationship between some variable and some outcome that we cannot make go away if we have a suitable number of covariates, right? Because the effects are small and everything is correlated with everything. So being very judicious with your covariates is a real challenge. So as a general, I hope I'm not moving too far away from the question, but as a general rule, we strongly advocate that people don't include covariates by default. And people used to do this. I'm doing an analysis, doesn't matter what it is, but I'm going to include sex and age and race and ethnicity and maybe socioeconomic status, and then see what happens. And that might be a very, very bad idea. And if you're looking at, I think you mentioned kind of socioeconomics and race, as we know, they're very highly confounded. To some extent, you can unconfound them because we have enough variation, but like not perfectly in our sample. So I think you have to, it's a bit of a trite answer, but you have to be very, very thoughtful about what your research question is and why are you covariating for this. And it might be very meaningful. I mean, you might want to look at socioeconomic effects unconfounded by race and ethnicity. Maybe you want to look at it in each race and in more stratified analysis, or vice versa. But it's complicated. I know that seems like not a really useful answer, but that's really the best. You just have to be super thoughtful as you go into it and not include covariates by default.
Well, Hugh, we're about out of time, but I just want to thank you for a wonderful presentation, and your Q&A was wonderful. And I'm just impressed by how humble and careful you are about this amazing set of studies, both with the infants and the adolescents. So great stuff. Thanks for being with us. Thanks to everybody in the audience and those who are online. And we'll see you on January 15th. Bye-bye.
Thank you.